Hello everyone. So in this video we will be discussing about structural steel, right? So let me remind you what we have discussed. We have discussed about cement first of all, then we have discussed about aggregates, then we have discussed about some properties of concrete, right? Creep, shrinkage and other properties. Then we are now discussing about structural steel. Right, so slowly we are moving towards the designing part. Okay, now I have told you in previous video why do we use only structural steel, why not some other materials. The reason is clear, because the coefficient of expansion of steel as well as concrete, they are quite similar. They are not equal, but they are quite similar. Okay, that is the reason. Now coming to structural steel, you must have seen the bars, you must have seen some construction, some column erection is going, some beam casting is going, some slab casting is going, right? So we must have seen some structural bars, which is known as the structural steel also in the concrete. Okay, now what are its properties, let us discuss, and then we will discuss about the stress strain curve also. That is very important. I have already told you about the stress strain curve of concrete. Now we will be discussing about the stress strain curve for structural steel, and then we will be solving some numericals. After that we will be moving towards the designing criteria or designing part. Okay, now structural steel has been classified basically into three types. So first one is the mild steel. As from the name it is clear, mild steel means the strength is mild. So mild steel is Fe250. Fe means iron. 250 is the yield strength. Okay. So what is the yield strength for mild steel? That is 250 Newton per mm square is the yield strength for Fe 250, right? 250 Newton per mm square. Okay. Now you can also write it like this: 250 Newton per mm square is the yield strength. Fy is equals to 250 Newton per mm square. Now what is yield strength? This topic will be discussed in a lot of details in strength of materials, but as far as the concrete point of view is concerned, I will explain you some important aspects of structural steel. Okay, now there I will be discussing about yield strength. Okay, Fy in the graphs I will be discussing about. Now coming to HYSD, what is the full form of HYSD? High yield strength deformed bars. So it is a combination of lot of words. High yield, it means that it will have high yield, it will be more than 250. It was mild steel, right? High yield strength deformed bars. Now what are deformed bars? So have you seen bars when you go to some shop, when you go to some cement shop, you must have seen bars. The structural steel bars, they are like this. Let us say this is a structural steel bar, and you must have seen some ribs on the bars. So what are these ribs? These types of bars are known as deformed bars. They are ribs. So why ribs are provided? So that the bond between the concrete and the steel is much higher as compared to the mild steel. Because in mild steel we do not have any ribs. There are no ribs. They are simple bars, simple plain bars. These are also known as plain bars also. Okay. So high strength, high yield strength deformed bars. These are of three types. Fe415 will yield strength of 415 Newton per mm square. Fe500 yield strength of 500 Newton per mm square, and Fe550 with yield strength of 550 Newton per mm square. 550 Newton per mm square. Okay. Now next one is the TMT bars. TMT, the full form is thermomechanically treated bars. So these bars are much more corrosion resistant. What is the reason is that how these are formed? These are formed, let us say that you have a bar. Now this is very hot. Initially it is very hot, it has come out of furnace, it is very hot, and the hot bar, it is put in cold water. The hot bar is put in cold water. So what will happen? Some layer of carbon and some other oxide, it get deposited on the surface of the bar, but inside it is still in the molten state. So these types of bar are known as TMT bars, or thermomechanically treated bars. These are highly corrosion resistant bars. Okay, so in the designing of concrete structures, what we are dealing with, we will be dealing with mild steel, we will be dealing with HYSD. Clear? Now let us understand the stress strain curve for these two, the mild steel as well as the HYSD. So let us understand that. Now let us see the stress versus strain curve for steel. I have already explained you about the stress strain curve for concrete, but now let us see the stress strain curve for steel. So first of all, how stress strain curve is drawn? Okay, so first of all, you know that you must have done this experiment in your college also, that there is a bar, steel bar. It is a steel bar. Okay, now it is held by the jaws of the universal testing machine. It is held between the jaws of the universal testing machine. It is held between the jaws of the universal testing machine, and this length is known as the gauge length, right? This is known as the gauge length. Gauge, gauge length. And what is the formula for gauge length? You must have studied this in your structural steel structures, that is equals to 5.65 under root A, where A is the area of cross section. That is how you determine the gauge length. Now you have got the gauge length, you have hold the bar with the jaws of the universal testing machine, and then you pull it. Okay, when you pull it, what will happen? Deformation will take place, and after some time the bar will break. Or at that time, what you do is that you draw the graph between stress and strain. Okay, so how do you get the graph? First of all, let me show you the graph for mild steel. First of all, let me show you the graph for mild steel. For mild steel, you get a graph like this. In books, initially it has been given as straight, but no, it is not straight actually. Okay, it is like this, a little bit parabolic. After that, you get a peak like this, and after that, like this. This is the graph for mild steel. Mild steel means Fe250. That is, Fy is 250 Newton per mm square. Yield strength is 250 Newton per mm. This is stress on y-axis and strain on x-axis. Delta L upon L strain, and stress is force per unit area. Clear? That is how you get it. This is the real stress strain curve for mild steel. Okay? The slope of the stress strain curve, what it will give to you? Again, I have already explained, it will give you the Young's modulus of elasticity. Okay? You know that initially up to this range, the stress is directly proportional to strain. If you remove the sign of proportionality, what you will get? You will get Young's modulus of elasticity, right? So Young's modulus of elasticity given by E into epsilon. Simple, right? Now the question is, this will be explained to you in strength of material also, that the yield strength which you are getting, which yield strength is it? Is it the, because here in this graph you are getting two peaks. One peak is here and one peak is here. So yield strength means the force or the stress exerted on a structural steel, okay, when it will not return back to its original position. Yielding means it will start permanent deformation after that point of time. Okay, so now here you have 2 points. This point, after this point also, if you remove the loading, it will not come back to its original position. And same point here. Here also, if you remove the load, it will not come back to its original position. So actually we have 2 yield points. This is known as the upper yield point, and this is known as the lower yield point. The question is, this yield strength for mild steel, is it for the upper yield point or for the lower yield point, and why? You will be explaining this is strength of materials, but this is important for concrete point of view also. That is why I also explaining you. Okay. The question is, this yield strength, is it the upper yield point strength or the lower yield point strength? Is it this? Let us say this is Fy1, or is it Fy2? Let us say this Fy2. Which one is this Fy? Do you know that? A lot of you may be knowing, a lot of you may not be knowing. The answer is This Fy or the yield strength is the lower yield point strength. Now let me tell you the reason, because this question has been asked in examinations. Okay. Now let me tell you the reason why lower yield point, why not upper yield point. Because you know that from the graph, this value will be higher as compared to this value. Clear? At this point also it is not coming back to its original position. At this point also it is not coming back to its original position. Now you tell me, let us say, if I say that if I punch you with a force of 100 Newton, I will knock you. And similarly, if I punch another person with a force of, let us say, 80 Newton, I will knock him, right? So what do you think is the least force with which I can knock a person? Is it 100 or 80? Obviously 80. So basically this is the lower yield point. Why? Because it is lesser. So obviously automatically it will be safer for this one also. If the bar will start yielding at this point, automatically it will yield at this point. So we are always taking the lower yield point as our yield point. Okay, so this was important. That is how this is the real graph for mild steel. But IS code has idealized this graph. What IS code says that, again the same concept of concrete, it is very difficult to determine the values at different points. So IS code has simplified this graph. What IS code says, it says that the graph for mild steel is like this: straight line and straight line. First elastic, then plastic. Simple. This is the definition for IS code. There is stress and this is strain. Simple. But the actual graph is like this. This graph you must have got in your laboratories also. Okay, under the universal testing machine. Okay, so this was for mild steel. Now second one, let me explain the stress strain curve for HYSD, that is high yield strength deformed bars. Okay, which is also important. Stress versus strain for HYSD. Okay. Now one more thing. The higher the strength, the brittle is the failure. What is brittle failure? You must have done this experiment in your college also. The HYSD, it breaks with a force, with a noise, you can say, right? Suppose that under the universal testing machine you are testing HYSD. Now when yield point will come, there will be a lot of elongation in the bar, and a breaking point will come when you will hear a lot of noise like doop, and it will break. Okay, so that type of break is known as the brittle failure. On the other hand, the mild steel, there is no brittle failure, there is a ductile failure. Okay, so it is very ductile in nature. On the other hand, the high strength bars, whether it is 450, 500, 550, they break in brittle failure. Okay, so how is the graph for stress strain for HYSD? Let us say this is stress in Newton per mm square. Let us say this is strain delta L upon L. So the graph is like this. You do not get a peak here. In case of mild steel, you are getting peak. Why? Because it will start elongated. A lot of elongation will be there. After some time it will break. But the HYSD, they break at a glance. Okay, they break. You don't know when it is going to break. It can break at any time. Okay, after the yielding point is achieved. Now the graph is like this. The graph is like this. Let us say this is for Fe. Let us say this is for 550. This will be for, sorry, this will be for Fe, let us say 500, and this will be for Fe 450. The graph will be like this. So you are not getting a peak here. You are not getting a peak here. If you are not getting a peak, how will you come to know what is the yield strength? So this is the question. Now here there is no peak. In case of mild steel, there was a peak. You can easily determine this is the yield point, upper yield, lower yield. It was very easy. But in case of high yield strength deformed bars, you are not getting a peak. So how will you get the yield strength? The answer is proof stress. Now what is proof stress? What you do is that this is a strain line. So at a strain of 0.002, at a strain of 0.002 or 0.2%, or 0.2%, what you do is that you draw a line parallel to the initial line. You draw a line which is parallel to the initial line. Okay, you draw a line which is parallel to the initial line, and the point at which it is intersecting the stress strain curve, this point is the yield stress, right? So this is the yield stress for this is the yield stress for Fe 500, and this is the yield stress for Fe 450. That yield stress also known as the proof stress also, right? So I'm not going in detail in that, but if you are not getting a peak, what you will do? You will draw a line parallel to the initial stress strain diagram. Okay, in one examination there was a question that the Young's modulus of elasticity for, okay, so the question was like, it was a theoretical question actually. So it was like this: which one of the following is correct? So first option was E for 450 is greater than E for 500 is greater than E for 550. The second option was E for 450 is less than E for 500 is less than E for 550. The third option was E for 550 is greater than E for 450 is greater than E for 500. And the last option was E for 500 is equals to E for 550 is equals to E for 450. So there was a numerical, not a theoretical question in some examination, right? I guess it was ES or some state PSC examination. So the question was like this: which of the following is correct? It means what is E is the Young's modulus of elasticity. And how do you get the Young's modulus of elasticity? It is actually the slope of a stress strain curve in the elastic limit. So you have to calculate the slope up to this. Let us say this is the elastic limit. You have to calculate the slope up to here. So initially, what do you think? What should be the answer? So initially, the slope of all the three is equal. Are you seeing it? Initially, the slope of all the three is equal. Okay, it means that if slope of all the three is equal, the Young's modulus of elasticity for all the three, HYS, that is 550, 500, 450 will be equal. It means the correct answer will be D option, that is E500. This question was not asked in GATE examination, but some state PSC examination, and it is a probability because I think this type of question can come at GATE also, because they are checking your concept, they are checking your imagination power. Do you remember the graph? If you remember the graph, you can easily say that yes, initially it was equal and after that they were different, right? So we are just seeing the elastic limit. Up to the elastic limit, all three are equal. So this was the question. Okay, so now you have understood the stress strain relationship for HYSD also. Now let us solve some numericals. So we have studied a lot. We have studied a lot of theoretical things. Okay. Now let us move forward and solve some numericals. After that, I will be also telling you the previous year GATE numericals, and in the next video, I will be explaining the most expected GATE questions, which I feel that can be asked in subsequent GATE examinations. Okay. So now let us solve some numericals.